My name's Junaid Mubeen. I'm Head of Product at Whizz Education, and we partner with parents and schools to raise standards in maths with our virtual tutoring service, Maths-Whizz. And I'll speak about how Maths-Whizz supports mastery in the classroom a little later. But first, I want to share something of my own journey through maths. So I'm a former research mathematician. I've studied and taught maths at various levels. But you know, if my mum was here, she would insist that I introduce myself as a former game show champion. So back in 2008, I fulfilled my childhood dream, and quite possibly hers, by winning Series 59 of Countdown. Now, I grew up on Countdown. It was always there waiting for me after school, 4:30 p.m. on Channel 4 with Richard Whiteley and Carol Vorderman. And I remember quite distinctly the moment that I got hooked on the show. And it was when this numbers game came up. So just a quick refresher of how it works. You have to combine these 6 numbers using the standard operations of addition, subtraction, multiplication and division to get as close to that target as possible. Now, if you didn't make it to 952, don't worry, this one is not straightforward. But there is a solution, and thanks to YouTube, we can relive this round in all its glory. So this clip is from 1997, and it gives us a glimpse of math mastery in action. You'll enjoy this.
Well, 952 then, James.
I think I have 952.
Okay, well, that'd be great if you have 952. Gerald?
953.
Oh, no, 953. Right, well, we've got a 953, Carol, and a 952. So let's have James's 952.
3 times 100. Sorry, can I do 100 plus 6?
Okay, 100 plus 6, yes?
Is 106.
Yeah.
Multiplied by 3.
It's 318.
I'd like to multiply by 75 now.
Multiply it by 75?
Yes, please.
Multiply this by 75?
Yes, please.
And then divide it by something?
Well, yes, in a minute, but... okay, that should... I'm not quite clear what that makes, but that's certainly what I'd like to do. 318 times 75.
So times 75, and then what will you divide it?
I'm going to take away 50.
Oh, good grief, I'm going to need my calculator for this one. 318 times 75 is...
Okay, let's work it out. 225 plus...
23,850, apparently.
Okay, now take away 50.
23,000, sorry, I've gone now. 23,800.
And divide by 25, I hope.
And divide this by... by 25. Do you know, I think you're right. That's incredible. I think he's right. 952.
So that's pretty remarkable, right? And that solution has gone down in Countdown folklore. It was certainly my inspiration as a young and budding countdowner. But how did James pull it off? Well, he got to 318 simply enough, and it's here that things get very interesting because he then multiplies by 75, ending up at around 24,000. And numbers this large are very rarely seen on Countdown, so you can understand Carol's hysteria. And then he subtracts 50, divides by 25, and somehow he lands on 952. Now, you may have noticed that James didn't actually know the value of 318 times 75, and here's the really cool part. He didn't need to know, because he was trying to get from 318 to 952, and he knew he could do it as long as he could multiply by 3 and subtract 2. Now, he had 25, 50, and 75 to play with. He knew that 75 over 25 gives the 3, and 50 over 25 gives the 2. The catch is that you can only use those numbers once each. And the really clever part is in how he combined those 3 steps in the middle, because multiplying by 75, taking away 50, and dividing by 25 in that order is the same as multiplying by 3 and taking away 2. It's basic number properties and order of operations. And so James didn't need to know those intermediate values because he knew that the overall effect would be to get him from 318 to 952. Now, that's not bad, and all within 30 seconds, no less. And this is a snapshot of maths mastery, that term that we've been hearing a lot about recently. And it all rested on James's foundational knowledge of maths. He knew his multiples of 25, his order of operations. He was fluent with his calculations. Now, I'm sure that James was not born with these number skills. He honed them through practice. Because when I appeared on Countdown, I would practice for hours and hours online. And I saw legions of players go from being really rather poor at the numbers game to producing these kinds of solutions at will. And that's the most exciting thing of all about mastery. It can be learned. And I'm convinced that everyone in this room and every student in this country can achieve the kind of mastery that we've just witnessed across all areas of maths. And the key is in having those foundations. And that's true for mastery of any skill, whether it's cooking or driving, playing golf or any other endeavor. Mastery is always built on solid foundations. And that's never more true than of maths. Now, my 4-year-old niece, Miriam, has recently gotten me into Jenga. Now, she's usually very resistant to my charms, but for some reason, we can bond over a good game of Jenga. And the more I play this crazy, addictive game, the more I realize it's the perfect model for thinking about how we learn maths. So Miriam is in reception, and very soon she'll go through roughly the same primary schooling that I did. She'll cover a similar maths curriculum, the same topics and concepts. Now, think of each of these concepts as a Jenga block. So Miriam will pick up these concepts one at a time. And because maths is hierarchical and deeply interconnected, very soon her learning profile will resemble a Jenga tower. Actually, this isn't Miriam, at least not yet. This is the learning profile of the best mathematicians. It's very sturdy. There are no gaps, there are no wobbles. But here's how things might play out for Miriam. Every now and again, she might get stuck. A gap might appear in her knowledge. That's perfectly natural. And there may be days where she's off school, unwell, and she may slip further behind, and so more gaps will appear. Let's take that one. If she's anything like her uncle, there will be days where she just struggles to pay her full attention. And so these gaps will build up over time. And if they're left unaddressed, then these foundations will start to look a little shaky. And Miriam will struggle to engage with more advanced concepts that depend on them. So let's say she struggles with whole number addition. She wouldn't be the first. Well, when she then encounters multiplication, that struggle will only grow because multiplication is just repeated addition. And then her gaps will deepen when she covers division, which is just the inverse of multiplication. And she'll stutter along through the curriculum until one day she's introduced to fractions. Now, fractions are notoriously challenging because they behave in unintuitive ways. And you cannot manipulate fractions if you do not know how to manipulate whole numbers. And so those struggles will only deepen as time goes on. And then at some point, a couple of years later, she'll meet probability. Well, fractions is the language of probability. And so that will be nigh on impossible. And so we have this whole tower of concepts, multiplication, division, fractions, and probability, that all rests on the foundations of whole number addition. And we'd better make sure that Miriam has really nailed those foundations, because she has a stack of advanced curriculum content coming her way. And if she has shaky foundations, she may not be able to bear it. That didn't quite have the impact we were hoping for, but even so, the point is that as Miriam's Jenga tower comes crashing down, so will her confidence. And she may be left to feel that she's no good at maths because those small struggles have blown up throughout her learning. And we hear that so often, I'm no good at maths. To say that I'm no good at English would be a mark of shame. But for some reason, we wear our struggles in maths as a badge of honor. But just imagine if we could readily identify Miriam's gaps at the point of need and address them. Well, she'd have the most sturdy mathematical Jenga tower. It would be built on solid foundations. And that is the learning profile of the best math students that I've ever taught or worked with. And you know what else is true of these people? They love maths. They do. They're full of confidence, and they derive deep pleasure from solving problems. And that virtuous cycle is so key to mastery. And I think psychology is very important here too. You may be familiar with Carol Dweck's work on the power of a growth mindset, that belief that our abilities are not fixed. And I think it's one of the most important ideas in all of mathematics, and something that we need to really promote in every interaction that we have with students. But we will not persuade students of their capacity for maths mastery unless we support them with the foundations. And then we'll see their confidence flourish as they build on concepts systematically. And that's my main hope for Miriam. Now, teaching those foundations is hard work. And that's because every child is unique. And as parents and as uncles, we celebrate that fact. And as well we should, because our rich diversity is what makes us human. But as educators, we're often challenged by it, because meeting the individual needs of every child can be very difficult. So let's take a typical classroom. And I'm going to share some data now that we've picked up at Whizz. This is a typical Year 5 class, and this visual shows the spread of learning needs in this class. And we have permission from the school to share their report. So each of these icons is a student, and this scale plots their overall maths ability that our Maths-Whizz virtual tutor has calculated. And we call that their maths age. It has a very similar interpretation to reading age, so we'd expect these students to have a maths age of around 10. But instead, what we see is a 4-year gap between the highest achieving students and the lowest achieving students. Now, Maths-Whizz serves thousands of schools in 8 international territories, and our research shows that that trend, that 4-year gap, is consistent in classrooms all across the world, whether it's rural Kenya or suburban America, or state and private schools here in the UK. It's a reality, and it really underscores the challenge for maths educators. How do you deliver an education experience that meets each child where they are, that supports each of them with those foundations of mastery? And actually, the challenge runs much deeper than we might think, because it may seem that we have just a few outliers to deal with, these high achievers at the top end and those struggling students over here. But in fact, every one of these students has fundamental gaps in their knowledge. And to see this, I'm going to take 2 students from within that middle cluster. So we'll start with Nancy. This is Nancy's learning profile from 2 years ago when she first started on Maths-Whizz. So these are the different topics in the curriculum. And these red markers show us where Nancy was placed in her initial assessment. Now, Nancy was around 7.5 at the time, and you can see that in most topics she was within the expected range of ability, except for that one at the top, place value. In place value, she had a maths age of around 5, a whole 2 years behind. Now, that's a pretty shaky foundation. How does that happen? Well, maybe Nancy was absent the week they taught place value in school. Or maybe she just didn't fundamentally grasp the concept of hundreds and tens and ones. Well, we know that Nancy's development as a mathematician will surely depend on a strong understanding of place value. And so we need a way to fill her specific knowledge gaps. And we have a way. The benefits of one-to-one tutoring have been known for over 30 years, and Maths-Whizz simulates the behavior of a human tutor. So it's all automated, and it delivers lessons in sequence according to each child's individual needs and pace of learning. And the tutor combines direct instruction with interactive learning. It uses continuous assessment to constantly keep track of each child's specific knowledge gaps. And it adapts, just as a human tutor would do. And here's a snapshot of what the lessons look like. And you can see they're very colourful and animated. They use rich and varied representations. This is what maths should look like. And I have to tell you, this is what maths has always looked like to me. Numbers and shapes have been dancing around in my head since I was 3. And I think every child deserves to be inspired and engaged by maths. I think that's one of the key ingredients of mastery, because you will not meet a mathematician who doesn't possess a deep love for their subject. And the tutor is embedding the fundamental building blocks of maths. Now, broadly speaking, there are 3 kinds of mathematical knowledge. There's the factual knowledge, the absolute truths of maths, your times tables, the names of the polygons, and so on. And there's procedural knowledge, knowing how to combine mathematical objects using algorithms such as long division. And lastly, there's conceptual knowledge, understanding the connections and structures that underpin the mathematical universe. So the what, the how, and the why of maths. Now, there's intense debate around which of these strands matters more, and which one promotes a greater depth of mathematical thinking. And the truth is that these debates often pose false dichotomies, because the research is very clear. You need to develop all 3 in parallel, because they depend on one another. And you ignore any one of them at your peril. And our countdowner, James, knew this. His moment of maths mastery depended on a very close interaction between all three. So let's go back to Nancy and see what impact the tutor has had on her learning. So Nancy's been on Maths-Whizz for around 2 years, receiving dedicated one-to-one support, and these blue bars show us her improvement in each topic. Look at place value. We can see that Nancy now enjoys a more rounded learning profile because the tutor has filled her specific knowledge gaps. It cemented her foundations. And this visual really embodies that growth mindset. It shows us that every child can enjoy steady and sustained growth when they receive that dedicated one-to-one support. And that continuous positive feedback can be the difference between maths anxiety and maths mastery, between students giving up on maths altogether and feeling a profound sense of mathematical identity. Now, I'm going to show you another student in the same class as Nancy, also from within that middle cluster. So he has roughly the same overall maths ability, and he has the same teacher, he receives the same support and instruction. So you may expect that his learning profile is very similar to Nancy's. And yet, this is Liam. Now, what was Nancy's weakest topic? Place value, right? Well, go figure. It turns out that was one of Liam's strongest. Now, we hear all the time that no two students are the same. And here's the evidence. Because we can see that Liam's needs were vastly different to Nancy's. He was fine in place value, but his shaky foundations were in fractions and pencil paper addition and subtraction. And again, after 2 years of interacting with the tutor, Liam also now enjoys a more rounded profile. He has solid foundations across the board. And so we have two students in the same learning environment with two very different learning profiles, and that's where one-to-one tutoring comes in, by adapting to each child's individual needs. And it works. Our research shows that students who spend 60 minutes a week on Maths-Whizz accelerate their learning by 18 months in their first year. Put another way, 60 minutes a week guarantees students the foundations of mastery. So that's the first piece of the puzzle. Now, how do we build on those foundations and guide students towards mastery? As a mathematician and as an educator, I know that some of the richest mathematical experiences take place away from the digital screen. And that's because maths is immersive. It has to be touched and felt. And maths is social. It has to be collaborative and full of discussion and debate. And maths is open. It has to be exploratory and full of discovery and surprise. And so the real power of a virtual tutor is in enriching the way that students interact with maths offline as well as online. And the lifeblood of maths is problem solving. Now, I'll confess plainly to my love for solving maths problems, that burning desire to find underlying patterns, and that euphoria of discovering a breakthrough. And there's a reason that mathematicians tend to be very tired. It's because we never sleep well on an open problem. So here's one of my favorites. One of my year 6 students brought this to me a few months ago. You have 4 copies of the number 1, 2, 3, 4. You have to rearrange the digits in each copy so that these 4 numbers sum to 9,000. So if we take these numbers as they are, we're some way off the target. If I reverse the digits in the top number, I can get much closer, but the goal is to hit 9,000 dead on. And this is a wonderful problem because there are many different ways to approach it, different strategies that you can use. It gives you very good practice in multi-digit addition. It builds your fluency. And my student rattled off many different permutations, but he couldn't quite reach 9,000. And neither could I. And after a while, you begin to ask questions. You confront your intuitions. You consider new possibilities, and you develop and test hypotheses. And these are the hallmarks of deep mathematical thinking. And it's all guided by your core knowledge of maths, in this case, place value and addition. Now, I'll leave that problem with you, and it may surprise you, and you may have more questions. And that's the real power of maths. That Jenga tower has no ceiling. Mastery runs infinitely deep. There are always more questions to ask, new patterns to discover, and richer problems to solve. And that is the essence of learning maths. We acquire knowledge, and we apply it to solve complex and interesting problems. And virtual tutoring is the springboard because it embeds that core knowledge. And in this way, I think virtual tutoring can really enrich the way that maths is experienced in the classroom. We know that the most important variable in all of education is the teacher-student relationship. And we also know that many teachers today are overstretched. And so we need to ensure that these technologies do not add to that burden, that they're easy to access and intuitive to use, and that they really free up teachers to support each child's individual needs and to focus on that deeper learning. So I think teachers need access to clear and actionable insights that identify students' needs and that guide their lesson planning and instruction. I think teachers should be able to direct virtual tutors to any curriculum topic so that the learning that students do online reinforces their classroom interactions. And I actually think the whole concept of tutoring needs to evolve, because teachers don't need tools that displace them, they need tools that empower them. And the real promise of virtual tutoring is that it embeds those foundations with such incredible efficiency that it empowers teachers with the time and resources to lead students towards mastery. And at Whizz, we strive to understand the individual needs of every learner and also the individual challenges faced by teachers. And that's where our service begins and ends. And we leverage technology, virtual tutoring, real-time reporting, and instructional resources to help teachers and schools achieve their goals. And so when we speak of raising standards in maths, of mastery learning, when we speak of technology and data, of blended learning and flipped classrooms, to me, it all comes back to a few simple questions. Is every child supported with the foundations of mastery? Are teachers empowered with the tools to enrich their lesson planning and instruction? And do schools have the insights that they need to achieve their curriculum objectives? And most of all, does maths look something like this? And if it does, then there's a very good chance that we're on the path to mastery. Thank you very much.